Yeah, I was going to do this. Run. We get a random partition, find the local maximum. This changes the partition, by the way. Then run over partitions that are found from this local maximum. I call it scatter, so just do something to it so we're not on the local maximum anymore. And then run the algorithm to find the local maximum from there again. And then find if there is a score that is better. However, the way I wrote this code implies that I have multiple ways to scatter it. And I didn't think that through, maybe. How can I do this? I don't know. Let's leave it like this, though. I'll just make a partition iterator scatter a thing that just returns a single partition. So this whole loop is then just one big, and then either it finds a better local maximum or doesn't. Partition iterator scatter.h. Iterator scatter.h. Why did it give me a compile error then? Scattered was not declared in the scope. Yeah, I guess it meant scatter. No, I didn't. I meant partition 2. Hi, Bear. Nice guy and Roman. no matching functions will call to partition iterator scatter partition cons reference. Yeah, I just copied this scatter partition iterator scatter from the partition iterator brute force. Totally not implemented yet. Oh right, yeah. This does not return a partition iterator. I'm going to have to do the same thing as I did for the brute force. We don't have a GPS here. I added a special B begin for that. Yuck. Yeah. I guess keep adding begin and ends like this, especially since I'm not even iterating over anything. Let's call this s end, s begin from scatter. Ones and zeros. I'll come back. Why is my partition iterator scatter not highlighted? Yeah, you know it is. I don't know what this is about yet. End iterator. Begin iterator and an increment. We might have an is end. That wouldn't compile. I want to test if it is compiling. Partition iterator scatter is not time type. In that case, I guess I have to rather this one. Yeah, let's add that here then. Also as a for declaration. Partition iterator scatter is incomplete. And it would not be incomplete here. What the? What? Oh, excuse me. It's a different file. And still he cannot use it. Because it's returning scatter now. Oh, it's not even returning scatter. I have to call scatter begin. And scatter end. And that is not working. Why? There is no operator on equal. Okay, I was using is end for the brute force, so I should use it here as well. Okay, undefined reference. So now I have to implement the thing. Okay, what is this? It is now linking with the partition iterator scatter.cxx, but we do not have an operator ++. Partition iterator scatter. Oh, no, we don't, indeed. Yeah, I guess I need one. Let's just add it. That would be a return this. Iterator scatter reference. And of course you have to add that then as well here, or I should already have it. Already have it. Just didn't see it last time. No declaration matches partition iterator scatter reference. There's a const here. cannot be const. It's pre-increment. Why is it const? I just copied the other one or something. Undefined reference to the constructor, which takes an int. Let's add a constructor. Yay, okay, so now I have to really cannot postpone it any longer. I have to think about how I want to implement this thing. So we are having some kind of partition. Let's say I think I still have that one partition. Say. Oh, that takes a long time. What is it doing? Huh? No way it's going to take this long. Okay, what the hell? Oh, I cannot recompile it because I changed it drastically. I think I have maybe still nope, I deleted that. Okay, I'll just make something up. So imagine we have the partition A, B, C, D, it doesn't really matter. Okay, I'll skip one. F, comma, D, G, comma, A, B, C, D, E, F, G, H, I. Bit short, but who cares? So now I want to scatter it, and one possible way to scatter it would be, say, to split off a pair or triplet. Well, it's exactly that's what I'm going to do. Now this is already a pair, and there's already triplets, but I could still split off a pair from this one. So I could turn this one into, say, see, that's what I'm afraid of. The number of pairs and triplets are enormous rather quickly. And then I would have to multiply with this one. The number of pairs here are 3. So say I do not split off anything here. Well, I will. I think I want to do all of them, maybe. Is in parallel-ish? Is that possible? I think so, yeah. So let's say we just start with splitting of AB. And then here we split of EH. So that would be 1. And then the next one would be splitting of EI, leaving H alone. And the next one would be just E alone and having split off HI. And then we do all that again, but now for a different AB, so I could split off AC, I guess. Razor, yeah, but don't ask me. Please don't ask. I need this to write an algorithm. The reason that I want random partitions is because I have an algorithm that cannot be perfect, and then therefore can be stuck in a local maximum, and while I'm searching for a maximum. So my idea was to just try out a lot of starting points randomly, and then the chances increase that I found a real maximum. And also simply for testing purposes. Let's see, AC is 1, and then I can combine it with F. And we are left over with BC here. So I split off AB and then AC and then AF, and now next I guess I split off BC, but I already have that. Yeah, okay. I could split off, if I split off anything else that does not contain A, except when I split off a triplet, A is going to be part of a pair of a triplet. In other words, we already have it. Therefore, I can move to the triplets. And I could split off, if it's split off a triplet, then only one thing is going to be left. So we get in total 4 more of these things. Might as well split off ABC, or we are left over, let's say, with C here and with B here and with A here. And that means that I have to delete C here and B here and A here. Right, so this would be what I want to generate from this one. I think that means let's split off a single pair from each group. Sorry, a single pair or triplet from each group. And then that multiplies, unfortunately, because I'm doing it for 2 groups at the same time. So splitting off, let's say we have 8 elements here and another group with 8 elements and another group with 8 elements, and that's gonna explode like crazy, but not that crazy. Yeah, let's say I want to kind of stop at some point. Maybe what I can do is just scatter off, let's say 50 or 100 and then just stop. Provided I'm doing it in a certain order. And I'm having ideas about that. And that would make it extremely difficult, but I don't really like that. Split it off. Oh my god. Really? Let me think. If I want to stop at some point, I need an ordering for these things. Now I can think of an ordering by just looking at the single pair or triplets. I already have that. But then when I have two of them, this is split up and this one is also split up. How about... How about I just loop through one of them until the thing that determines the ordering becomes less than the ordering in the other one. Yeah, that means that I need to have an iterator that iterates over a single group and returns a score for what it did. And then I can implement the whole thing. So let's call that one a group iterator scatter. I think. Yes, so this thing here is called partition iterator scatter and it returns a partition after dereferencing it. And I think I want to implement it in a, well, difficult way, but for that difficult way I'm going to need a way to iterate over the scatter of a single group. Meaning, if I have this group, I need an iterator that generates these groups here. But not really these groups, because I can calculate the second group if I have just the first group. So I'm going to iterate over this. So having this, I want an iterator that iterates over these. Well, these are times 3 because I already have these. So actually I wanted to iterate over just AB, AC, AF, all the pairs. So we get also BC and the BF and CF, that's all the pairs, but also all the triplets, ABC, and then ABF, ACF, and BCF, right? Yeah. So having a group with 4 elements, I want to generate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And they have to be ordered in a certain order. The order that I want to put them in is sorted by the binding between these elements. Some pairs give a really high score, so they should be tried first. Okay, let's implement that first then. Let's just make a copy of my partition iterator scatter. And we're going to call that group iterator scatter. Which then has nothing to do with this. And I guess we can just copy the group that we are running over. So I'll call this the original group. I can just store that. Oh, that's not the end iterator, but okay. Fix that in a minute. Original. Let's make the end iterator simply the default constructor. And then we have still have to implement these 2 functions. Let's put them for the moment in a. I'm going to delete this multi-loop until I need it. You need a group here. Well, I can eventually inline this one, so it doesn't have to go here. This one is already inlined. So we might want to implement this one in the .cxx file. And that one is already inlined if I even need it. Now we're going to implement this one in this .cxx file. Okay, let's see. I'm just returning a group, of course. Okay, I have to add this one as well. So we create, well, let's begin with the end iterator. The end iterator must be recognizable as being the end iterator, aka one past the end, and not contain a state that could happen for a real iterator. And now the default constructor of group, this one, calls the default constructor of elements type, which is the default constructor of bit set, which I think initializes absolutely nothing. That is, it calls the default constructor of the base class here, which is built-in type struct, so it's probably uninitialized. So we cannot use the default constructor of the group. I ran into this before. We'll have to do something difficult. An empty group, however, would be a good way to recognize the end. I mean, empty groups, we are not dealing with empty groups while iterating, and it's yeah, well, the most logical choice, I suppose. So I want to create a group that is empty. Element cannot be empty because it represents a single element. So you'll have to use this one and therefore explicitly pass an elements type that contains no bits. This is a bit set. And that means that we have to pass I'll have to use this mask type thing here. I did that before. And I think it took it 2 minutes, so let's try to find it back. That was something like that occurred in it, and a 0. Yep, there it is. So this is a way to get the 0 group. Rather, we just have to pass this to the constructor of the group. Right, so that would be our end iterator. And now we have to recognize it here. Is end, well, it's the end if the group is empty. Now I have to test that. I think that my bit set simply has an empty, or has a none. But my group has an empty, that would be very suitable. Original dot empty. So after constructing it like this, we have no bit set, which means that the bit set has no bit set. Yeah, so this one is empty here. That would be the end. And the begin iterator simply, it's not that simple. We make a copy of the group because we continuously need it to generate the next one. But we also need then loop variables, and I think that the loop variables must be, we are generating a pair or we are generating a triplet. But I also have to do it in the correct order. Hello, unknown user. Yeah, it's not easy. There's two ways, I guess. We could just generate them all in advance and then sort them. Or, but that might be slower in some cases. So it kind of depends on the size of the original group. Where is the tipping point? Nobody knows. So all these have to implement both and then maybe do ish test. We're definitely going to need to know how large this group is. Number of elements in the group. Well, we only have is single bit. Because I'll just add it. Well, my bit set should have one. So we're going to the bit set and then see if we can find a function that returns the number of bits that are set. Count. Returns the number of bits set to 1. It's a standard size type. Oops, I'm going to edit the group. Right. Now let's do that only once and just store it. Meaning knowing if we have enough elements. Let's say boolean use method B. Use method B. Why not? So use method B is then true if the number of elements in origin is element count is larger than a certain value, Well, that actually, I think it kind of depends. The tipping point depends on the number of elements in total. But for now, I'll just say 8. Just to fill in something. And now I have to implement 2 methods. Let's say implement method A is we generate it in advance. Okay. Let's add it here. False. Generate all results in advance. And then sort. And true then is the other method. That means we run over run over all possible pairs and triplets in order of score. I don't feel like explaining it completely. To implement it still. Anyway, I'm going to need the internal state for these things. So this one needs us to generate them all in advance. And sort them at score. So we need a score, I guess, a map. A standard multi-map. Score, comma, group. And that would be method A. Does multi-map have its own header? To ensure. Okay. I think I have to include score separately. Right, so we're going to generate this thing, and then we just have we have all of the answers here. So there would be this whole list here, sorted by score. So I'm just starting at the top, and then I stop after a certain amount. Let's wait a minute. No. We're going to do them all. The maximum number of results is limited for the partition iterator. This thing just needs to be able to run over all of them. So we need to know where we are, and then get the next one. If you call plus, doesn't that mean that we just need an iterator into this multi-map? I think so. Usually for every container, I just make a using container type. But this is specific for method A. Method A container type. And then we take method A container type iterator. So also can be const iterator. and we call that current method A. I don't know what's in the name. I'm getting more and more easy about my naming because this is just a test-ish application, not the real application. At least not yet, but well. Okay, so when this is initialized, which is here, no, not really. I have to generate it. I'm going to have to move this to the .cxx file because it's definitely more complex and then fits in a header file reasonably. Can I already add elements for the members for the method B? I think method B is using a table that I'm generating elsewhere. I think that one is still in partitions. Where's my, yeah. Simple. This one, I think, yeah. This one, score. Well, this one is ordered by score, and this group is just all the pairs and triplets. We're going to need that, I think, only in the file, in the .cxx file, and that we are creating. So I might as well move this code there. So let's edit group iterator header, moving it to there. I'm doing this. Yeah, damn it. That's a constructor. And if use method B, now we do method B, and otherwise we do method A. Where method A involves the code that we found there. Yeah, nah, I have to do that globally probably. But let's copy it. So I also have to do this. I think that all this can go. It uses G-scores. Prints result. You have to do that outside of the constructor, I think, because we might have multiple group iterator scatter things and they all use the same data. Which kind of means that this must be a static function of our class. Let's call this static. Let's just call it initialize or something like that. And the result is then in scores, 23, on this one. So this should be accessible later on, so this must be a static thing. Let's call this s underscore, and then I'm moving it out of here. And we're calling it, it's a static member of this class. I'm still printing it here, it's maybe not necessary anymore, but okay, so this means that I have to add static member and this static function to group scatter. Okay, so this is needed for method B. Did I add a static thing? Oh yeah, so I just forgot to add a static here. Now I have to call this function to initialize it, but only once. I can call it from the partitions, or you can call it from the constructor. In the case that we are using method B, there's something with the once flag, or something like that. Once flag. Let's see if I have another window open. It's also partitions. Let's go to Linux viewer. I already used it there. Okay, all the progna onces. Too much. How about once flag anyway? No. STD once. Also no. Pretty sure what's called once flag. Standard once flag. And I did not use that. Why is there no example here? Be on the call once. Yeah, so we're gonna need a once flag, and might as well also be static, I guess. Simply pass the flag to standard call once. That should do it. No. Let's make this one static as well. S in, not M underscore, but S underscore. And then we have to call this one, right? Grab scatter initialize. I think this thing wants really a function pointer or not? What do you think? Probably both works, but let's do it like this. Or not. Nah, not here. Just avoid something and then they pass it without passing a pointer. So hopefully that works without it as well. So the first time we get here, we're calling initialize. Hopefully blocking every other thread that tries it as well. Well, we only have one thread here. It's not multi-threaded. Okay. And that then initializes S scores 2, 3, which we then can use. Method A then is, how is method A working? Method A was working like, we're just going to fill this map here with the score comma group. Which means that we have to generate all the groups. Yeah. I guess we have to iterate over the bits like A, B, C. I think as people are more or less watching. There's a lot of people that have it more or less in the background, I understood. I'm not sure. Okay, so we need an iterator that runs over all these bits, and then another iterator that runs also over the bits, but is larger than the previous iterator. And then in the end, even a third one. If at all possible. I mean, at the time we have CF, there is no beyond this thing. Yeah, okay, so group is, I'm going to have, it looks like it would have to access whatever group is wrapping, namely elements type, which is a bit set, but that would be bad coding. Better is to let group handle what group can access. So I'm thinking about a way of allowing me to run over all the bits in a group, aka all the elements in a group. What kind of API would I need? It doesn't have it now. I can just add a remove groups, toggle elements, but I cannot run over all the elements in the group. I think I should have to simply add a begin and an end to this class, which then runs over all the elements. That should do it. Unfortunately, now, well, a bit set does have that, I'm pretty sure. At the very least it should. Reset, set, flip, shifts, size, count, least significant bit, most significant bit, least significant bit index. I could use this one. There it is, the very end. So that returns a bit set const iterator. And now we lost kind of touch with what our element has, or does, or is. That is what happens if I dereference this type. So where's this const iterator defined? That will be here, and then we call the dereference operator on it. Oh, I implemented it in a smart way, I see. And this stores the whole bit mask, I guess, yeah. Then every time you call plus plus, it removes the least significant bit. So if there is no bit left, let's say if there is one bit left, then, well, let me explain this. So if you have here, we have a bit mask. Say we have like that, and then you call this function. Then first it's subtracting 1. So if you subtract 1 from this value here, which is binary value, obviously, we get 0, 1, 1, 1, 1. And then we do a bitwise AND. Well, these are all zeros here and all ones here, but all those ones are cancelled because there's bitwise AND is only a 1 again if both are 1. So the result of the bitwise AND is that. So effectively we have removed the least significant bit, like the comment says. And if we do that on the last one, we would get 0, obviously. And this together we get 0. And if you do it on 0, so we have 0, whatever, still delete this. We have 0, we subtract 1, and now we do an AND, it just stays 0. So if there is no there's no bit left that is set, then nothing happens, it just stays 0. Right. And the dereference operator then, now we have to find that back. Operator star, this one returns the least significant bit. That does returns AND, bitwise AND of mask and minus mask. So it's not even using assembly instructions to search for bits or whatever. They exist, but so for example, if we have this one, with this mask like before, and we do this, well, if you make this negative, it becomes I think in bit inversed -1, right? Bit inverse +1, I think. Yeah. So a negative value is this one in bits inversed. +1. If you add 1 to this, you get that. And now we do the bitwise AND, so you get just the least significant bit. How cool is that? Anyway, the thing that it returns is again a bit set, but then a bit set with a single bit. There's a single bit set here. If we want to know the actual index of that bit, then we have to use a special assembly instruction. But I don't think we need the index. We can just work with the mask. Just the mask. Okay, so I'm going to run over. We're going to add this begin and end to my group class. Not super happy that it does that, but okay, just call it a const. It's actually going to work. It is going to work, yeah. We just get a group back, not an element. We get a group back with a single element in it. That's the trick. So this is my group. What the heck, I'll add it here. Begin is then returning elements begin. So elements type is the bit set. So now we just have the bit set const iterator. Oh, this thing has a T. Well, that is uint32 type, but I can just use elements type mask type, which is the T. It's kind of ugly, but elements type mask type. Have to pass the same type to the considerer. Or I could just use auto, because elements begin and end, of course, return the same type. But well, this way I can see what the type is. Let's call that end. Begin is const, right? Yep. Okay, so now we have a begin and end, therefore we can iterate over them. How awesome is that? And I want to do that for method A in the .cxx file. So I can call begin on our group, which is original. And then we can loop over that. So I'm gonna do an element iter. What's in the name? Element iterator is unequal origin.end. plus element iter. I must say I'm kind of curious how the end is implemented, but I hope it doesn't matter. I'm not 100% sure yet. I think the next loop, because we have, yeah, let's remove the iter. I'm gonna use substitute no iter. And then we call this element 1. The problem is that my next element must run over the remaining bits. I don't want to, generate AB and then later BA. I just want to generate AB. So the B is larger than the A. But how to find the next element? I think the first element can just run over all the elements that are in this group. And then the second one, we can say you can just begin at element 1. And then we just simply start with an increment. So that means that I have to put it outside the for loop, I think. Yeah. So now 2 starts 1 bit after element 1, if that exists, which gives us all the pairs. But you also need triplets. I would like to know what the end is. If end is just, well, I mean, no, it's just too dirty. I would say if it can dereference the end iterator and it gives me an empty group, that would be nice, but it's just too dirty. No dereferencing end iterators. Shotgun, yeah. It seems that most of the bandwidth of YouTube goes into recommendations these days. They just don't have more bandwidth to recommend it more often. I'll be right back because... Give me a minute. Right. I'm back. In the case of a triplet, we would redo this again. So this way we would find all the triplets, and then I think that at the end I just do it again for the pair. The thing is, it would be nice to not have any code duplication. So if I do something in here and then I have to do that again outside of the for loop, I would rather detect inside the for loop that we are reaching the end, and then do it again-ish. So I think I want to create my pair. So this is a pair or a triplet, which I always call 2, 3 elsewhere, like here, 2, 3. Group 2, 3, yeah, group 2, 3. So either 2 or 3 elements. And this group will definitely have the first 2 groups. So how can I make a group? What the hell? Yeah, see, what? I think I press caps lock. Don't press caps lock. Okay, we're back. Group. I only have add here. I don't know why I did not just implement an operator or. But well, let's stick with it. We just have this. I'm going to have to call add on it. So we can construct a group from a group, right? I mean, that would be nice. No. Well, I think we should. There's probably still copy constructor that is generated by the compiler, just so be possible. So I'm going to create my group from the first element. Dereference the first element, gives a group. And now we're going to add the second element. And now we're going to add the third element only if it is not already end. How well that? Which means that I'm not stopping when it is end, when we reach end here. So we do if element, well, let's do it this way. Boolean last element 3 is element 3 equals int. Well, that's not last, it's more past. So more like no element 3 means that element 3 equals that end. We're actually going to enter it, so I'm deleting this. That looks weird, but okay. And then if not no element 3, we're adding element 3 as well. And now we have created all pairs and all triplets at this point. But we still have to break out of this loop. So here is a if no element 3, break. And we get out of that loop. Right, and what do you want to do with that? I want to look up I want to look up the score, so I need a group to score. Oh, right. Well, I made that one here as well, group to score, but it's not static yet. Shall we keep that as well then? As a static one, I mean. Yeah, why not? So let's make this one a static one. Static. Which means we have to declare it in a .cxx somewhere, aka here. And declare it in the class. Okay. So this gives us this pre-calculated score. Actually, maybe it's stupid because this costs a little bit of memory. And I don't think that calculating the score of a group is that intensive. Is it? I mean, I can just call score on a group, which does the following thing. It gets... Oh wait, I can only call score on a element pair. Yep. Okay, too difficult. So for a triplet, I have to find, reconstruct the pairs, the 3 pairs, and then look them up and then add them together and all whatnot. So let's use our new static map to get the score. What were we doing exactly here? Filling something. Anyway, the score of this thing is equal to as group 232 score, passing our group 23. And then we're going to fill the method A container, which is a multi-map from score to group. And then we're done with all the pairs and triplets that exist in this group. We're going to sort it. What is this? Multi-map. Does multi-map have its own sort? I have no idea. I suppose it does. Multi-map. Nope, no sort. So which containers do have their own sort? Because that's more efficient than the general one. I just search for sort. We have standard sort, ranges sort. Oh, list has its own sort, but I don't see any others. That's interesting. There is a standard partition. I have to look at it. Yeah. Right, so what was I doing? Yeah, we call standard sort, I guess. Standard sort on our method A. Huh? What? It's that kind of nonsense. Method A is already sorted. Yeah, I'm completely losing it, as you can see. My god. Really. Multimap is already sorted, so there's no sort necessary at all. Not for map, not for set, not for multimap, not for multiset. So, then what do I want to do? Guess we're done here. This is just the initialization, the preparation for doing method A. There was a preparation for doing method B. I think we're done then with the preparation, aka the container. Can I try to compile this, or did I miss something seriously? Definitely missing something. Pragma wants a main file. Notes of file directory multimap. Guess it is included in map then. Just define the map. Kaioru, how long have you been programming? So long that I'm on my way back, as you can see. It's, so I started when I was 12, so that's 46 years, of which 28 years C++. You can wonder why on earth someone who does C++ for 28 years doesn't know that there is no multimap header. Well, first of all, I don't have memory anymore, so like it's incredibly bad. Secondly, map and multimap and all that good stuff doesn't exist that long, so it exists less. I think like when did they start with? I don't know. Anyway, I never use multimap, almost never, so I just didn't know. I always include map for map, and multimap, yeah, it's just not my thing. It happens, so I didn't know it. There's an error here. Error const iterator in using elements type is utils a bitset unsigned int, aka bitset unsigned int does not name a template type. Oh, really? Well, I guess that's a good thing. Could have sworn there was a T there. Does not name a type either. Really? What the fuck, dude? Instantly adding a disk back. No return type in. Yeah, it's full with errors. Zip. Return and return. I did an interview once for my job. It was a job interview. And the guy asked, it was in Dutch, so how to translate that to English? Something like, can you stand or can you deal with compile errors? And I thought, well, is he crazy? Is he asking like to see if I'm lying or something like that? I mean, I don't know. I had the feeling he was like maybe expecting me to, try hard to come across as a good programmer, and then answer something like no, but unfortunately I never have compile errors or something like that. Well, like compile errors that's the life of a programmer. It's nothing but compile errors. I'm not sure anymore what I answered, but probably something like I use compile errors to get my program working. So I really don't mind. No. Anyway, the job interviewer in the end was the only one who did not want to hire me. But they hired me anyway because of the boss. My boss wanted to. There was a how do you call those guys? Public relations or no? Public human resources guy that did the interview. And then he advised against hiring me, and then the guy who had brought me in said, "Yeah, fuck you. We're hiring him anyway. Right? You're mistaken." So it was a weird kind of interview. I didn't use it. I told the story before, maybe, I don't know. It was a funny story, it's not that long. So after I was done with university, I just sat home playing with my computer. And my mother had told me, I was already into open source. So my mother said to me, Carlo, you have to go do job interviews. They will not come to your door. And the funny thing is that at some point, someone from a certain company did contact me with questions about my open source thing. And as soon as I figured out he was from a company, I was reluctant to help him because I thought, I'm doing this as a volunteer, open source and stuff. And this guy is from a company, so why would I give him my time? But, well, he persisted, so I was like, I'm not going to do this over email. It takes long. So I told him, well, if you really want an answer, just come here. And he did. So he came to my door. And then soon the questions about my software changed into more or less a job interview and talking about the opportunity to work with him as my direct boss. So that's kind of funny, yeah. That they did come to my door. That was in Delft. It was for my PhD. So I did university in Eindhoven, and then I went to Delft. begin end. We have this. I don't know what is wrong. I must have opened this file because of some reason. What was the reason? See, that's what I mean with bad memory. Partition does not name a type. Well, it does. So maybe I just, and I end up in this line. What are we? Partition. Oh, it's a different file. Okay, we still need, but you don't need partition here. This thing returns a group. Right. Element pair was not declared in this scope. I don't need an element pair. Oh, I moved the whole stuff here. Yeah, so we need element pair, I guess, and loads of other stuff. Element pair. What else do we need? Once flag. Include mutex. Probably the same file, right? And then we get our standard once flag is not a static data member. Did not add it. Yeah. At which point you can delete this again. Damn it, my keyboard is eroded so much I cannot read the keys anymore. Sometimes it's annoying. I mean, it should know where the keys are. Most of the time I'm just typing, but if I look at my keyboard to make sure where the D is, I just see blanco keys there. Yeah, see that now it's going wrong. I mean 2DD. And I'm okay. I'm not going to buy a new keyboard just because my keys are unreadable. So it's a weird thing. I mean, another keyboard that I have is so eroded. It's like the plastic of the top of the key is like millimeters deep. Gone away. Think of my fingers excrete some kind of acid. Something like that. Okay, I delete it from here, and now I go to the header file, and we go to the top, and now we paste it here, and then I add this thing to here, and then static, and that can be private. Just add it here. D to F colon. So a better way. Make. Nikos, you live in Eindhoven? That's cool. Or anyone. Does anyone live in Eindhoven? Let's meet. Let's drink coffee somewhere. I'm not doing alcohol, so it has to be coffee. Error, invalid use of void expression. Okay, what is going on here? I'm doing standard call once twice. Now you are going to the university in Eindhoven. Aha. Well, I've been there. Oh, that's physics. What are you doing? Are you studying computer science? I don't even know if they have that in Eindhoven. Okay. Cannot convert utils bit set to group. Yeah, we get back a bit set. And I have to convert that to a group again. Well, it is because it is explicit. So, but isn't it already an elements type? The elements type is literally the bit set. So I can pass bit set to the constructor of a group. Huh? Hello, Tom. Okay, well, Nikos, explain this to me. Element 1 is the return type of the begin call of morigin, which is, let me run C tags again. Origin is a group, and now we call begin on the group. Group begin. So that returns a utils bit set const iterator. Therefore, element 1 is a utils bit set const iterator. And then I'm going to do the dereference of that. So we call the operator star on it. And the result of that we use as an argument to the constructor of group. So we call the operator star on this thing here, which means that we get back a bit set. We have the same type as we passed to the as a template parameter. I pass to the const iterator. In other words, since I pass the same mask type, we just get back our bit set here. It is definitely a bit set. It's just, it says it here, bit set. Don't tell me it's anything else than a bit set. Where is this bit set defined? Must admit I don't see it. Oh, here it is. Bit set. So it's utils bit set. Forward declared, but still. So this is a utils bit set, and lo and behold, group can be constructed from explicitly, but okay, from elements type. Elements type is a utils bit set with the same template parameter. So why is that not working? Because if I try to compile this, I get the error cannot convert utils bit set unsigned int, which is, if you ask me, an uint32 type, to group. Okay, which one should work? Initializing argument 1. Or I want to see candidates here. No candidates. Oh, this one. I was looking at the wrong bloody line. Yeah, this one is logical. Because it is an implicit constructor. Actually, bit set. Bit set is an elements type. Yeah, of course. So that's correct. I have to cast it. Oh well. Lost a lot of time. I was looking at one line higher. Why? This is an elements type, not a group, and a group can be constructed from that, but only implicitly. No return type. I did not implement this yet. Yeah, we should leave the warning. Okay, so I think we have implemented this one more or less. Group, yeah. So no, we didn't. This compiles now, and now I have to implement this. Okay, so I'm going to need an iterator inside this method A thing that I already added to the class. What I did here, current A. So after we fill method A and sorted it, or it is already sorted, that thing should just be initialized as well to the first element. We can do that in here. Current A points to the first thing, and then of course if we just dereference that, and we just we call this the reference thing here, and then we just have to use this, which returns what was this thing? Group score to group, right? So this would be second. Yep. And then if we want to increment it, that would also be simple. We just increment this thing here. Except that if we reach the end, we must set our iterator to whatever end is, which was What was I using? I was setting this group to empty. So we must set original to empty if we reach the end, which means that we are definitely not going to go backwards. The end is really the end. Let's see. Well, I think I just want to make it a clear, something like that. I mean, because why not? We have a none here from the bit set. Might as well. Yeah, we have a bunch of elements, and then a partition is a way to put those elements in a bunch of sets. So you create a bunch of sets. Is that not Googleable? Not really. I'll tell you as soon as I get back to the code where I have a comment about it. How can I reset this thing? What is the engine for? To make games, to make anything on my computer that requires graphics, 3D graphics. I do not have a clear. That's pretty amazing. Bit mask. Yeah, here it is. Reset. Yeah, I hope so too. I hope so too. Yeah. Is it possible this thing ends up empty? I guess it is possible if, say, it has just one element. I might as well also skip it if it is 2 elements. Otherwise it cannot be empty. I need to add something here. And in this case, if we increment this and it becomes equal to the end, that would be a method a dot end. Then I have to clear my group. And that is just origin. I think it's orig clear. And we should only do this. Let's first do this one. And dot here. If something, then clear, and then do not this, do not that, do nothing. Could just return, I guess. Turn. Yeah, which means when do we do that? We do that if the number of elements is less than 2. I think I already have that stored somewhere. Thought I stored that. Okay, so Control T. Oops, no. This one. If origin dot, it was element count, I think it was. Element count is less than 3. Then we do nothing. Although we should never get here, probably. Probably test it sooner. Let me think. Yeah, it's kind of nonsensical. I'm going to change this into an assert. Yeah, might as well already add that to the constructor. Oh, this is a constructor. Waha. Okay. Oh, here I'm calling it element count. Yeah. So now I'm calling it twice. But okay, this is an assert. Right. So then. I think this should work now. I think we can test it. Yep, let's test our group iterator scatter. I can just do that at the top, I think. No, we cannot. Oh, we can. So we should be able to do that. Return. Okay, vulkan. Let's return 0. Group G. Okay, I don't know how many elements I have currently. Let's say we have, I'm going to need at least 5 elements. It is going to fill it with all. No, it is not interesting. Let's make 10 elements. And then we'll just do every other or something like that. I should be able to do this like A, B, D, F, G, J, something like that. They're not really iterators. I'm just abusing the name and the begin and end member functions. Partitions. I have a feeling it's not working. ABD forever. What about the beginning? It starts at ABD and it never ends. Am I not incrementing my iterator? I'm not incrementing it, am I? Doing something very stupid here. Yeah, very stupid. I think it works. My eyes are burning. I don't know why. I have that problem more and more. It seems that I'm allergic for my own eyes or something like that. So we have A, B, D, F, G. I want to see the beginning. Let's see if I can remember that. Okay. So we generate triplets first. A, B, D, F, G, J, A, B. I guess A, B has a very high score. Then we get ADF, ADG, okay, something's wrong. It's not sorted at all. It's just in the exact order that it is being generated. What? Right, the score is 0 for all of them because I'm not generating the G scores yet. I really have to do that first. Maybe I should move that into that same file as well. G scores happens here. Let's see. Yeah, this is filled with random numbers, so it's not really part of the algorithm. So I'll just have to do this first because it is being used. On the other hand, it's kind of strange that it is being used while it is a super test thing. Let me just move it down to below where scores is filled. That should be here. No, I have something else. Okay, I can put it here. Could be fucking kidding me. It's still alphabetic order. I'm going to print, this is new Vim. I'm going to print the score as well, I guess. It should work. Not sure. No, it does not work. Yeah, I'll just have to make it a group first. Yeah, okay, so we can see it's not sorted at all. That's surprising me. But I'm sure it's something super stupid again. This is running over the iterators. Iterator group iterator scatter by calling this on, which means that we increment m current a. And m current a is an iterator, a const iterator of m method a m method a, which is a multi-map sorted by score. So if we run over that, we should get the highest score first, right? So what the heck is going on here? How is this possible? Getting random scores. Is a multi-map not sorted? I mean, I guess it doesn't have to be. Like I said, I never use multi-maps. Maps are sorted, I'm sure of that. But multi-map, I don't know. Sorted. Multi-map is a associative container that contains a sorted list of key value pairs. Of course it's sorted. While permitting multiple entries with the same key. Sorting is done according to the comparison function compare applied to the keys. Search, insertion and removal operations have logarithmic complexity. Yada yada. It should be sorted by score, by the key. Okay, let's go closer to the source. As soon as I have filled or initialized a method A, I'm going to print it. So here we do inserts, and then we're done when we end this stop here. So at this point we're done. Let me run over all the elements. Auto. We don't know what it is. Element in M method A. And let the debug library handle printing. I'm just going to print it. E. Okay, that's clear. The score is 0. That's why it doesn't get sorted. There's nothing to sort. The real score is this. So for some reason we don't have any idea what the score is. What the hell, man? That would mean that this score is always 0. Which would mean that as group 232 score is not filled or whatever it is. Let's make sure of this. That's going to print all the scores here. That's kind of silly, but let's say the group printing it completely. Go 2, 3. Gives us a score of score. Yep, everything is 0. So is that not initialized then? Should be initialized. It's getting initialized here, for example. And there. So yeah, that should happen when this is called. Maybe it's not called at all. Let's print it when it is being called. And it's not called. Okay. It's kind of strange because we're passing this like literally here to. Oh, method. Yeah, that explains. So I'm also using it when using method A. I didn't know that. Let me think. Yeah, that's correct. So that it was nonsensical. This has to go here. And now it's neatly sorted from -1, -5, -15 to -5 again. Very sorted. Totally convinced that this is correctly sorted. What's going on here? Oh, we have here all zeros and then 1, 1, 3, 5, 5, 5, 9, 11, 9, 11. Yeah, that looks sorted. I think I'm ignoring, in this list, I'm ignoring the negative values. Does that make sense that I'm doing that? It's kind of far-fetched, I think. Adri, why would you be able to understand what I'm doing? I mean, this is just text. It's nothing difficult, I think. So if you would be here continuously every day, for many hours a day, then you would know exactly what I'm doing. Or I could explain it just, again and again and again and again. But at some point you get tired of that, so I'm just doing my thing. I'm also a little bit scared to make people tired of it, People that watch this stream often, then they have to go through the same explanation every time. You mean the code? I mean, I want to know what you feel that you should understand. You mean this code? This is C++, basically, but heavy use of custom classes. How long, when did you join? How often have you watched my stream, Ed3? Just to get a feel for how much I must explain. I have a NP incomplete problem that I want to write an algorithm for, which is of course impossible. So it's mostly heuristic. I'm just doing something by feel, like, yeah, this might work. Playing around a bit. Anyway, what I have is a lot of a number of elements which I name by the characters in the alphabet: A, B, C, D, E, F, G, etc. And each pair I assign a random value between minus infinity and plus infinity. And then I try to find a partition such that if you add all the scores that I assigned to pairs whenever two elements are in the same set, or I use them group in the code, then I'm looking for the highest score. So the partition with the highest score is the solution. And the algorithm that I have now just tries to find a higher and a higher score by moving single elements from one group to another, or merging two groups completely together. And that gets stuck a lot in some kind of local maximum, doing it that way. And now I'm working on a scatter that, say, if I end up in a local maximum, I'm just going to do something rapey to the partition that I have, the local maximum, and then run my algorithm again. And then I hope that from the scattered partitions we will find another local maximum, or maybe even the maximum. And I'm doing all of that for a lot of random partitions, randomly generated partitions. So then I think at least one of them should end up in the actual maximum. Yeah, no. Yeah, I'm only storing scores when they are positive. So the negative ones are not stored, which means that all the negative ones get a value of 0. I don't know. Oh, right. So that explains why we're jumping up and down here. I'm completely ignoring these values. I'm setting them probably at 0. So all of this is nothing. All of this is actually 0, and therefore there is no sorting. But when they become positive, they must be sorted, and then they are 1, 1, 3, 5, 5, 9, 11, 94, 98, 100. Yeah, so totally sorted. So it works. So these things are now sorted, and it's kind of logical, I guess, that triplets have a higher score because they exist of 3 pairs instead of 1 pair. That is almost not fair. Maybe I should divide the triplet score by 3 and then sort that. I would do that, and 205 divided by 3 is still pretty much higher, but not higher than 100. So DG in the F would be really at the top then, AD as well. Let's see, 205 divided by 3 is 68. So yeah, it would become the 4th. So these 3 would get at the top, and then we get all our triplets. Well, not all of them. The highest one here is 5, that is 15. So these 2 would also disappear below the FG. Yeah, I don't think dividing by 3 makes much sense. I'll leave it like it is. Okay, so what I'm doing next then is I can run over these. I must be able to run over these pairs and triplets from the highest score backwards. Let's remove a few debug outputs. I don't think I want to print this anymore. Right. Partitions, let's see XX. I think the best thing is to sort them in the reverse order instead of running over them in the reverse order. And I need an R begin and stuff like that. Do not like that. Yeah, so really we want to store. How can I store this in reverse order? Can I do this with like this? Looks like I cannot. Standard grader. Dude, I have no idea. Can I add a my own comparator, I guess. It's not compiling. Mismatch argument 3 template parameter. So is grader not type? Oh, you have to pass the key. Yep, so now it runs from the largest value, etc. down. I think that is the end of... no, wait, I still have to implement method B. Ouch, yeah? Yeah. So this works by generating all the pairs and triplets. And for the pairs are almost generated for free. So let's just look at the triplets. That means then that we run our... If there are 8 elements, we have like 8 times 7 times 6. So 336 triplets, and then a little bit more for the pairs. So basically plus 8 times 7, 392. And then for each of those, I'll look up what the score is, and then I sort all of that. But say if this thing is much larger, like say we have 26 of them, then that would not be 394, but that would be 26 times 25 times 24 plus 26 times 25 is 16,250. Still not really big, actually. Still not big. Maybe I don't need method B. Yeah, the only difference method B is that I calculate, or I have determined all pairs and triplets, given the whole alphabet as it were, or all the elements are involved at all, not just the elements in this group. And then I can start at the top and then verify if that triplet occurs in my group with a single assembly instruction. unwrap it and all, so it's something like a quarter of a clock cycle or something. But then I still have to run linearly over a vector of I don't know, 16,250, and then do bit compare for each. And yeah, that is faster, but still, it's probably, I don't know. It's I don't care about the speed, I think, so at the moment. So I'll just stick with method A, which means that for now I'm going to delete method B. Right, now then I have to implement the group scatter, the partition iterator scatter in terms of the group iterator scatter. So here are examples of the partitions. So I just have A through I guess, and then there are lots of different ways to partition it. And in fact, I'm starting with this partition, and now I want to write something that generates these partitions from this. And the way I do that is I'm going to have an iterator that iterates over the group scatters for each group that has 3 or more elements. And then I'm going to increment the iterator that has the lowest score. So alternating, we're incrementing them. And then I'm going to stop after this a certain count. And that then will be it. So I'm not really going to generate this, I'm going to generate something else. But they should be listed here. I'm thinking if I have to really take special measure for skipping groups like this. And yeah, well, not. Why not? You can just have an array of iterators. It's not a multi-loop, right? No, this is different. It's more like a three-way merge thing. Or a zip merge or something like that. Okay, so I'm going to need a vector of group iterator scatter objects. Vector. Insist on this indentation. Group iterator scatter. Yeah, well, I think that's our state. Now, the end is obviously one that the vector is empty. Which I think is a pretty fast function. So we can use that. And then the end iterator is already correct. We just make a default thing which is empty. The begin iterator is called with a random int to make it different from this one by overloading. So that's called from returned by as begin, isn't it? Partition scatter. Yep. So I just pass 0 here, but it's not used. And now we have to implement the plus plus and the dereference. But yeah, and also this one for the initialization. So it's kind of the same thing as the group iterator scatter, but more complex. Let's go here. So this initializes our vector, and I guess that means we run over all the groups in this partition. I wish I knew how. All the groups, which groups? Let me think. I think I also need a partition. I'll just make a copy of it. It's not how iterators work, but it is in my case. Every time even. So for these partition iterator things. So we again have an origin. Original, I mean. And then, okay, so we have to run over all the groups of this partition. Well, we have an array. Let's see what else I have. Group, yeah, group begin and end. Groups end. That would be array end. So that would be including all the empty groups. But I guess that does not really matter. Groups is a lone group or first empty group. You can also use the group index. I have the first empty group index. Otherwise I would just have to check if the group is empty, but I can do that because I have to check if there's at least 3 elements in it anyway. So let's just run over all the groups and then stop when we see an empty group. So I'm going to use this one. Oh, that returns indexes. Let me see, can I get something? Yeah, we can use this one and then get the group by index. Yeah, I think that's the only way actually. At least the current API. Could change my API, but well, let's start to stick while you have. So in that case, I can have group index. Yeah. Why this is auto? It's confusing. With electroshocks 6 AM. Every time you make an error, give yourself the shock. It should be pretty quick. Groups is an utils array. Yeah, that should be, well, that's, yeah, definitely, that's group index. So. G begin and G end, I guess, or maybe not G end, but first empty group would also work. Or not, G begin. Yeah, sorry. Okay, running over all the groups. That is, now I can get a group here. I forgot to delete the space. I don't see where did I forget my semicolon? You forgot the semicolon. There's a delay between video, I'm afraid, and the chat, so. Maybe you mean here? don't think I missed a semicolon. Otherwise the compiler will have to point it out. I'm having my group here, and then I need to figure out if the group has how many elements the group has. We added that today. That was element count, right? Element count. It's a mysterious reason that is an int instead of an element index thing, but I guess that is okay. Okay, where am I now? Where am I now? Well, there it is. Element count. Called on, I'll just call it element count. Called on my group. And then if g equals 0, and Steinsky Volodya, have you any idea how much I'm paying YouTube for that? No, nothing. I'm not paying them. So if g is 0, then we are at the end, and I do not have to continue, so we can just break out of it. And if g my s element count, and if element count is larger than 2, then we want to do something with it. Namely, add an iterator to the begin of the group iterator scatter of this group. So I need to be able to get a group, already have the group. Okay, group. And I can get from this an element. No, I have to create an element scatter thing from it. A group. Iterator scatter. Created from the group. And I want to store in my vector these things. Well, I have that. So what I really want is just to place it. Yep, I think so. I'm thinking about all kinds of optimizations, but I should not spend crazy amounts of time to write super optimized code, I think, for this, because I have digressed too far. This isn't even the Vulkan engine anymore. I think I should just write some inefficient code and get it to work, right? Yeah, so what we have here is all the group iterators that I want to run over. The problem now is that yeah, the problem happens in the ++ thing. let's skip that anyway. So let's implement this one. Oopoo, that means that I need to return a partition. So we call that result. And I probably should simply begin with origin. And then apply our stuff. Stuff being this vector here. So we're going to apply stuff and then we return results. And in order to apply stuff, we have to loop over it. So that would be a group iterator scatter object, which we can access by const reference, I think. Let's call it a group iterator scatter thing again. And we run all that. Hopefully this works. And then for each group, I must remove this group from one of the groups of the partition. Which one? Ooh, I did skip certain groups, so that's not trivial. I can make it trivial by storing the index also in here. So the group index should also be stored in the group iterators vector. Let me run ctags again. Okay, so this applies to a certain group. I just want the group index, I'm not sure yet. Let's get it again. The group index is an guess second. And actual group iterator scatter object. This thing is pretty big, right? And it stores a complete container. So let's do that by const reference. And that is then igis first. And now we have to do stuff. I think at this point I'm first going to try to compile it. And fix all the errors. Error expected unqualified ID before equals. Yeah, that did not add any variable name here. So this is the real guess. And this is actually a pair of two things. Let's call it GISP. I'm so going to regret these abbreviations in the future when I have to look at this again, if I ever have to look at it again. But yeah, I'm being in a hurry. It's taking too long. As non-pointer type pair. GISP is a pair. Yeah, of course it is a pair. First, second. Would not convert 0 from brace and closed list to partition iterator scatter. That is correct. We have to pass the partition here. Can still not do it. This is unavailable in static member functions. Really? Yeah, okay. So it does not have to be, it should not be static. Yeah, compiles. So what next? Let me see. We run over all the iterators, and then I have the group iterator scatter. I think the thing calculates a group, right? So just make a group out of it. And now I want to remove this group from this group in the current partition. All that is in result. And I think partition doesn't have a remove, right? Yeah. Group has an add and a remove, and I'm allowing add and not remove. Why? Could add remove as well. I'm just gonna add it here. Why not? Remove from group index. I think it should be the other way around. I think I can swap these two and then get compile errors where they are being used, right? Yeah, you cannot create a group index from a group, so that should work. Let's swap this one as well. A group. So I have a remove here. Now I have a remove from. So I want you to call remove from index G. On or no, not original, on result. So we remove certain elements from this group. It leaves elements because it has more than 2 elements. And what is a good thing? If it has 3 elements, we should not generate a triplet that is the whole group. Have to change the group iterator scatter not to do that. Yeah. And then I need to add a new group. And before I forget it, have to sort it again at the end. I need to add a new group, so for non-existing group, to the partition. How do we do that? I can get the first empty group here, but I can call that once, I guess, and then insert at that point. Or I could just do a pushback, which seems more logical. Let's sort number of groups alone, group of so const stuff. Group. Yeah, kind of have to do. Oh, it's an array. You can only assign it. Yeah, that means I could call add as well. Add with a certain group index. That's probably then the best thing to do. And 2. I'm going to call first empty group. Got to do that, I suppose, somewhere. Let's call first empty group on result, and that is then an int, isn't it? Or what was it? No, it must be a group index, yeah. Group index, first empty group. Ouch. It's only a range abbreviations. So we remove these elements from GI and we add it to VAC and increment VAC as well. And we do that for everything, all the group iterators. And that should do it, I think. Cannot convert const. What is this? It's unrelated. Oh, yeah, not unrelated. New element. Well, not using it yet, but it compiles, as it were. Wrong file. I think I should stop and do something else because I just want to. Either I can continue till 2 AM and then I have to go straight to bed, or I can stop now and then still have time to satisfy my addiction to play a certain game on my tablet. I promised a friend that was visiting me today that I would be in bed at 2:30 AM. Because I'm going to bed later and I always keep my promises. So I think I'm going to stop now, and then I have basically 3 hours left until I have to be in bed. Yeah, I'm going to continue tomorrow. So, good night in advance.